Okay, the moment you've all been waiting for, 3.5 factoring review. Now, I'm going to go quickly through this because there are 4 pages, and I want to make sure that you know that you're not just supposed to copy them down. You're supposed to try them first and then check with the video just to see if you're following the steps the right way. And remember, there's always more than one way to solve a problem. I'm just trying to give you a quick way that we've been taught in class so that you can get through this, and be fluent with it. Okay, here we go. Okay, here's the factoring review worksheet, and I want you to see that I have a little fact chart here that we're going to look at to make sure we're doing things the right way and looking for the correct factor, so that we'll be using that. Okay, it says factor each binomial or trinomial expression and then circle our answer. All right, we're going to follow those directions. All right, so first we have a binomial. That means there's 2 terms, 1, 2. Okay, and we're going to factor them. So to factor them, we have to take out a common factor. And a common factor with 3 and 15, if you look on this chart, you could see a 3 and a 15 are both with the 3's. Okay, so we could take out a 3. Oops. Hold on. Okay, so let's factor out a 3. I gotta get my tools right here. Okay. To factor out a 3, we're going to divide out or factor out a 3. 3 divided by 3 is 1x, and 15 divided by 3 is 5, and that's a positive 5. And so this right here would be our factored binomial. Number 2, we have 2 and 10, and a common factor with 2 and 10 is going to be right over here. 2 and 10 right here would be a 2. And so you want to actually look and see if you could take your smaller value here and see if you could divide that out right away. And we can, because we ultimately want our y to be a 1. So let's factor out the 2. Divide them by 2. So 2 divided by 2 is 1y, and 10 divided by 2 is positive 5x. Now you might think you're done with this problem, but you're not, because it's not in standard form. We have to make sure that the x's and y's are in order. So this would be 2, 5x plus, instead of writing 1 over and over, that's just kind of clutter. We're just going to write y, because we know that that's 1y. This would be our simplified, in standard form, binomial expression. Okay, so now I have 2a minus 4, and I notice that 2 is the smaller of the 2, and that will work. And so I could factor out a 2, but I have to be careful because the first expression, or the first term here, is negative, so I have to take out a negative 2. So I'm going to divide out a negative 2. Now I divide 2 divided by 2, negative 2 divided by negative 2 is a positive 1a, and a negative 4 divided by negative 2, see the 2 negative signs right there? That'll give me a positive 2. This 1 right here is clutter, so we will just write out for our final simplified expression, negative 2a plus 2. Simplified expression. All right, moving along. Okay, I just noticed I missed number 3 over here, so let's go over to number 3. We'll bring our chart with us. Bring this chart over here, and we'll look at number 3. Okay, I have negative 16a minus 8x squared. I'm going to factor out the 8, but yeah, But I have to notice, is this written in standard form to begin with? No, because I have this term that has a squared variable. So I'm going to put that first. 8x squared minus 16a. And now I'm going to factor out that 8. So divide by 8, divide by 8. 8 divided by 8 is 1x squared. I don't have to write that 1. 16 divided by 8 is 2, but that's going to be, there's one negative sign, so negative 2a. So this is my simplified expression, or factored expression. Okay, I have 4 and 12, and we have to write this in standard form. So negative 12p plus 4. So now we can factor it, and I see there's a negative sign here, so I'm going to have to factor out something negative. I'm going to factor out the 4 because they both could be divided by 4. Okay, so 12 divided by 4, or negative 12 divided by 4 is negative 3p, and 4 divided by 4 is 1 plus 1. So this is our factored expression. Okay, now this is the one where I would use the chart at 12 and 36, and I'm going to find something that has a 12 and 36, and I think it's going to be over here in the 12 column. There's a 12 and there's a 36. 12 and 36. So let's look at this other one. There's a 12 right there. So 3, they could both be divided by 3. Okay, so let's move that out of the way. And here we go. Let's factor out a 3. So, and I notice I have to factor out a negative because there's a negative right there. So a negative 3, divide by negative 3, divide by negative 3. Negative 12 divided by negative 3 is a positive 4x. Negative 36 divided by 3 is going to be a positive 12. Is that right? Could something else be factored out of that, Riley? Between 12 and 36?
6.
Oh, let's look at 6. Hold on a second. All right.
Or 12.
Can we factor out 12? Oh yeah, we can factor out 12. What was I thinking? All right, let's get rid of all this right here. I wasn't right, and I'm sorry about that, you guys. Okay, I was going too fast. All right, I'm going to factor out a 12. 12 and 36 is in the 12 column. I'm sorry about that. So it's in the 12s. I'm going to factor out the 12, and it's going to be a negative 12. I even said, make sure you think that there's a negative there, or there's a, use your smallest value here. Okay, so negative 12 divided by negative 12 is going to be a positive 1, so 1x, and negative 36 divided by negative 12 is going to be a positive 12. 3, sorry. Oh, I'm sorry, you guys. All right, 3. And that right there is the final factored expression. Sorry about that, but if I waste my time going back and erasing all that, it would just waste more time. So, okay, number 7, here we go. I see x, y, those are in the right order. I see 3, 21, and 9. I know they can all be divided by 3. And I could look at my chart if I had to. 3, 21, 9. All right, so I'm going to factor out the 3. Up. Why does it do that? Okay, so I'm going to factor out the 3. 3 divided by 3 is 1x. 21 divided by 3 is 7y, and it's a positive 7y. And negative 9 divided by 3 is negative 3. So that is the final simplified expression. Okay, so now I'm looking at number 8. I have 15C. Okay, I notice right now I'm not in standard form. So I have to go 15A plus 15C plus 10. And I know I could factor out a 5, and that's my lowest one here. So I'm going to divide them all by 5. 5 divided by 5 is 1A. 15 divided by 5 is a positive 3C. And 10 divided by 5 is a positive 2. And this is my final factored expression. Okay, this one, number 9. I have 4S, 8W. That's in alphabetical order, so I'm good there. I see a 4, an 8, and a 20, and I know they could all be factored out by 4. So divided by 4, divided by 4, divided by 4. 4 divided by 4 is S, and it's going to be positive S, or I'm not writing 1, so 8 divided by 4, that's a negative 8 divided by 4, negative 2W, and negative 20 divided by 4, negative 5. And I just want to make sure you know that this should not look like an S. You got to make sure, or it should not look like a 5. You want to make sure it looks like an S. So you could use a lowercase s like that, or you could just make sure it looks like an S. All right, fine. Oh, that's your final simplified expression. Okay, we got to move this guy out of the way. All right, here we go. I see negatives. I see it's in the correct order, A, B, C, so we're good there. The first term is negative, so I'm going to factor out a negative and probably a negative 7, and those could all be divided by 7. So divide by negative 7, divide by negative 7, divide by negative 7. Negative 7 divided by negative 7 is a positive A. Negative 14 divided by negative 7 is a positive 2B. Negative 28 divided by negative 27, positive 4. And do you see how these subtraction signs turn into negative signs? They're interchangeable. That's your final simplified, or not simplified, factored expression. Okay, this one I could see is not written in standard form, so I have to write negative 5x, because that sign goes with it, plus 20y plus 35. And I could see that 5 is going to be my factor, and it's going to be a negative 5 because the first term is negative. So divide by negative 5. Okay, you ready? Negative 5 divided by 5 is 1x. 20 divided by negative 5 is going to be a negative 4y. 35 divided by negative 5 is going to be a negative 7. And it's negative because a positive and a negative is a negative. That's your final factored expression. Oh, yay, we made it through. Oh, no, we're not. We got one more to go. Thought we're almost done. Okay, here we go. We got to put it in standard form. 16, that's negative 16a plus 12c minus 32. 16, 12, and 32. Okay, I do have to look at my chart on that one. Where to go? All right, here's my, oops. Sorry to mess this up. Riley, don't tell me. Don't tell us the answer. Here, wait, why is it? Okay. I don't know why that's not working for me. So forget that chart for now. And we're going to go with 4. That's fine. Okay, let's take out a 4. Are we going to take out a positive or a negative 4, Riley?
Negative 4.
Why?
Because there's more negatives.
No, because the leading coefficient is negative. So negative 4. Okay, so divide them all by negative 4. Negative 16 divided by negative 4 is positive 4a. 12 divided by negative 4 is what, Riley?
-3.
Negative 3c. And negative 32 divided by negative 4 is
Negative
positive
8.
8. And that is my final factored expression. Good job, Riley.
Thanks.
All right, we are finally done with that page. And look at my math chart. It disappeared. Oh, look at number 7 isn't done. Why is that not done? Is that the one I messed up on? Yeah, this was 3. We factored out a 3, so that'd be x plus 7y minus 3. Okay, let's go to the next page. Okay, here we go. It says simplify each expression, then factor the simplified polynomial and circle your answer. Okay, got it. Simplify first. Let's go alphabetical order with m. Negative 5m, positive 8m. When I combine them together, I have to subtract. That will give me a 3m. And it's positive because there's more positive. And now I have n and negative 7n. That will give me a negative 6n. Done with that. And I have positive 4 and negative 4. Those cancel out. So now to factor, I see a 3 here. And I'm going to take it, factor it out, divide by 3, divide by 3. That's going to leave me with an m, and this will be a negative 2. 6 divided by 3 is negative 2n. Final simplified expression. No, final factored expression. Riley, let me ask you now, what would you start with if you were going to simplify that?
The x's.
Would you take that negative sign in front of the 4?
Yes.
And this positive sign in front of there. And what
Yes.
would you have if you had a negative 4 plus 1x?
Negative 3x.
Negative 3x. Then what would you take?
The y's.
Negative 7, positive 7. Those cancel out. They're 0 pairs. So gone. So now we're left with what, Rye?
Positive 2 and positive 1.
I don't see a positive 1.
At the very beginning.
Ooh, there it is. Good eye. So this isn't going to be a 2 right here. This is going to be a what?
3.
3. I'm glad you went through that with me, Rye. Oops, called you my sister. All right, so now let's factor this out. What would you factor out?
A negative 3.
A negative 3 because there's a negative in the first term. This is going to be an x. This is going to be a negative 1. Right, Rye?
Right.
There we go. These are fun and tricky, aren't they?
Uh-huh.
It's like a puzzle. Let's start with what, Rye?
A.
A. So 7a plus 2a is how many a's?
9.
9a. What are you going to do now, Rye?
C.
8c minus 8c. Psh, what happens to those, Riley?
They cancel out.
Why?
Because it's plus 8 and minus 8, which is 0.
Yep, those cancel out. We don't even have to write that down. And now, plus 1, plus 8. Remember, I'm done with those. That'll give me plus 9. So now, what can I factor out of those two?
Positive 9.
9. Right, positive 9. 9 divided by 9 is 1a, but I'm not going to write down the 1. Oops, I did, but I don't have to write down the 1 because it just means a. And 9 divided by 9 is a positive 1. Final factored fun expression. Okay, wait, I need to get this thing out of here. This thing just messes me up. All right. Number 16. By the way, for those of you in the audience watching, Riley is my daughter, who's way better at math than I am. All right, what would you start with, Rye?
K.
Alphabetical?
Yep.
4k minus 8k.
Negative 4k.
Negative 4k. Done with that, done with that. Now what? This is fun because I have these different colored pens I could use right away. It just makes it kind of easier to see.
Green?
Because it doesn't show up that great. Okay. Negative 6 plus 8.
2.
Positive 2m. And then I have plus 1 plus 5 equals plus 6. What can I factor out of this?
2.
2. See that
Negative
2
2.
right there? But it has to be negative because the first term is negative. Okay. So negative 4 divided by negative 2 is a positive 2k. 2 divided by 2 is a 1m. That's going to be a negative m. And 6 divided by 2 is going to be a negative 3. Final simplified, or not simplified, factored expression. 17. I'll use green this time, Riley. What do you want to start with?
The x's.
Okay, there's a positive 8x, positive x. That's 1x right there. So how many x's are there?
Positive 9.
9x. Done with that, done with that. 4y plus 8y is a positive 12y. Done with that, done with that. 7 minus 1 is a positive 6. What can I factor out? Can I factor out the 6 because it's the smallest?
Nope.
No, because I can't factor out 6 from 9. So let's go with what goes into 6? 3. Positive 3. Divide by 3, divide by 3, divide by 3. 9 divided by 3 is 3x. 12 divided by 3 is a positive 4y. And 6 divided by 3 is a positive 2. There it is. Okay, here we go. Get this guy out of here. All right, this is number 18. We're almost there. Okay, what can we take out here? Let's start with x again, because I got x and y's. Negative 4x and a negative x. That gives me a negative 5x. Done with that, done with that. Negative 2y, negative 8y. That's negative and more negative. Gives me a lot of negative 10y. Done with that, done with that. Negative 3, or positive 3, negative 8. 3 minus 8, negative 5. What can I take out? Immediately I see 5. It's going to be a positive 5 or negative 5, right?
Negative 5.
Why?
Because leading is negative.
The leading term is negative. Divide by negative 5, divide by negative 5, divide by negative 5. That will be an x, a positive 1x, positive 2y, and a positive 1. Factored expression. Hey, that page is done. All right, let's go to the next page. We are almost done with this. We can do it. Keep plugging away. Okay, I have to simplify this. I see those parentheses, so I know how to distribute. 3 times 5, 15x. 3 times negative 2, negative 6. And write everything else down. Okay, so now I have x, 3x plus 15x is 18x. Negative 6 plus negative 3 is negative 9. What can I factor out? I think I can factor out that 9. Divide by 9, divide by 9. 18 divided by 9, 2x. 9 divided by 9 is a negative 1. That's it. That's pretty fast. Okay, here we go. We have to do what first? Distribute. But I'm going to put a little 1 here just to remind myself that that's a 1. So negative 1 times 4 is negative 4x. You could bring down that minus, or you could go negative 1 times negative 9 is positive 9. And everything else stays the same because they're not in the parentheses. Okay, now I can combine negative 4x plus an x. That's a 1x. Negative 4 plus 1, negative 3x. And 9 minus 3 is going to be a positive 6. And I could take out the 3, but I have to take out a negative 3 because the first or leading term is negative. Divide by negative 3, divide by negative 3. That's going to be a positive x minus 6 divided by negative 3 is a negative 2. Final factored expression. Okay. Here we go. 21. Boy, that looks so much fun, doesn't it? Do you do problems like this in 10th grade?
Yeah.
Wow. Okay. We're doing like 10th grade work, right? This is good stuff. All right, let's distribute. Negative 3 times negative 1 is 3. Negative 3 times positive 8 is going to be a negative 24x. 3 times 9, positive 3 times 9 is going to be a positive 27x. And a positive 3 times a positive 7 is a positive 21. Combine negative 24x plus positive 27. That's going to give me a positive 3x. Done with that, done with that. 3 plus 21 is going to be plus 24. Factor out a 3. Divide by 3, divide by 3, 1x, and a positive 8. Wow. Did that simplify or what? Look at all of this. And we simplified it, and we came down to just that. Isn't that crazy? Let's simplify our lives. Our math lives. Okay, we're almost there. Here we go. 6 times 3, 18. 6 times n, positive 6n. Negative 4 times 9, negative 36. Negative 4 times 6, negative 24n. Okay, let's put our n's together. Do you notice I'm taking the sign with the in front every single time? 24 and a 6, that will give me a negative 18n. 18 minus 36, that's going to be a negative answer. I'm really doing 36 minus 18. That's going to be 18. Is that right, Rye?
What?
36 minus 18, 18?
Yes.
Okay, I'm going to factor out, well, obviously 18, but I have to factor out a negative 18 because the leading term is negative. That's going to be positive n and a positive 1. Okay. Ooh, double parentheses and negatives. There's a 1 in front of this one. Okay, so negative 1 times 2 is negative 2n. Negative 1 times 5 is negative 5. Negative 4 times 1 is negative 4. Negative 4 times 7n is negative 28n. Combine my n's, a negative 2 and a negative 28. That's negative and more negative is a lot of negative. That's negative 30n. Negative 5 plus negative 4 is negative 9. Let's factor out. Can I factor out a 9? No, because a 9 times something doesn't equal 30. So let's factor out a 3. And I'm going to factor out a negative 3 because we have a negative lead term. Okay. Divide by negative 3, divide by negative 3. 30 divided by negative 3, that's going to be 10, positive 10n, and that's going to be plus 3. Done with that. One more to go on this page. Here we go. Ooh, look at a bunch of negative signs and parentheses. Woohoo! Can do this. Negative 8 to start distributing times negative 3, negative 24. Negative 8 times negative 3, negative 24y. This is a negative 1. Negative 1 times a negative 1 is going to be a positive 1y. Negative 1 times a positive 9 is going to be a negative 9. Negative 24y plus 1y will be a negative 23y. Negative 24 minus 9 is going to be a negative 33. Can I factor anything out of that? Did I do it right?
Yes, you did it right.
That is it. I don't think anything can be factored, right? Wait, did I do that? Let me check my answers. Yeah, I got, this should be a 25. I did something wrong here. I know what I did wrong. A negative times a negative is a positive. A negative times a negative is a positive. I totally messed this one up. So wait a minute. I'm just checking my mistakes. Why'd you say I was right, Rye?
I wasn't paying attention.
Right. Okay. That's a positive and a positive. This is a positive and this is a negative. So 24y plus 1y is a positive 25y. And 24 minus 9 is going to be a positive 15. And I'm going to take out a 5. Positive 5. Divide by 5. Divide by 5. 5y. That's 50 divided by 5 is positive 3. So I left my mistake in there to show you that, look how easy it is to make a mistake. You can, and then I happened to catch it, thank goodness, because I don't want to show you guys the wrong thing. But that happens. Okay, let's go to the next page. We're almost... Okay, that looks like a lot of reading on this page, but we can do this. We've been doing this all week. Write an expression that meets the following requirements. Has two terms, contains a variable x, and has a coefficient of 7, and has a constant of 5. Okay, here we go. Two terms, and has an x. So one, it's going to have a variable of x, has a coefficient of 7. There you go, 7x. That's one term. Has a constant of 5, so 5 is going to be by itself. And I have to write an expression, so I'm just going to put a plus there. That's it. Or I could write 7x minus 5. Either way, it has two terms, contains a variable x, has a coefficient of 7, and has a constant of 5. Good. Write an expression that meets the following requirements. Contains three terms and contains the variables a, b, c, and has the coefficients 4, 5, 6, or 4, 6, and 2, and has only subtraction. Oh, that's easy. All right, so three terms. A, and it can be only subtraction. B, C, the coefficients have to be a 4, a 6, and a 2, and contains only subtraction. Okay, so let me write this neater. Ready? 4a minus 6b minus 2c. That's it. That has three terms, three variables, 4, 6, and 2, and contains only subtraction. Okay, here we go. Refer to this algebra expression. M squared minus 7n plus 4. How many terms? 1, 2, 3. How many identify the coefficients? I just see 7. Identify the variables. I see an m and an n. Don't write m squared because squaring it is an operation. M, the variable, is the variable of the letter itself. What operations do I have? Plus, and that's it. Just plus and plus. I just write down plus once. The only constant I have is 4. And can it be simplified? No. Because nothing here can combine together. So then you write no here. Okay, we're almost done. How many terms? 1, 2, 3, 4, 5. 5 terms. How many coefficients? I see a 4. I see a 5. I see a 7. And I see a 2. Variables. I see a C. I see A. I see B. And a C again, but I'm not going to write that down twice. The operations, I see plus and I see minus. Constants. I can't erase. I need to erase some of this, but it won't work. Okay. I see 3. Can it be simplified? Yes. How do you know? The C and the C can be combined. So to write the simplified standard form, I start with a squared, 5a squared, done with that, 7b, done with that, 4 minus 2 is a positive 2c, and that constant is by itself. How many terms? 2. Coefficient 8, 6. Variable z. Just write z. Don't write z squared or z9. That's not a variable. That's an operation. The operation here is plus. The constant is none. Can it be simplified? No. No. Last one. How many terms? 1, 2, 3, 4, 5. Coefficients? None. Variables? X and Y. Operations? Plus, minus. Constants? 1 and 5. Can this be simplified? Yes. Let's simplify it. Start with x squared. Nothing goes with that, so x squared. Y minus y, that cancels out. So no more y's. -1 and -5 is a -6. And that's it. We made it. We did it. All these pages are done. Congratulations. I hope you just kind of tried it yourself and listened as we went along, and when I made my mistake, I hope you understood the mistake and thought it out too. Okay, thank you. Bye.